Hey, welcome to week 4. This is about my third time recording this because something was wrong with the sound the 2 times before. Anyway, so we want to talk about, whoa, don't do that. Can't see it if it moves around. Relations. Now, we're not talking about your kinfolk, folks. We're talking any set of ordered pairs, including the 5 ordered pairs that you see right here. Now, we can have millions and trillions of points, but we only have 5 in this particular case. The next definition that you need to know is domain. The domain of a group of ordered pairs is the possible x values. I'm going to apologize right now. I'm tired, so I'm hoping I'm not going to yawn a lot because I know it's not fun to listen to somebody yawn in a video. Now, the possible x values I see here are 2, 8, 0, and hey, that's it. 2, 8, and 0. Now, do they have to be in a particular order? No. If you want them to be in a particular order, then just put them in a particular order. I don't care. It's fine. Do I have to write the duplicates? Because I see an 8 and a 2 there. No, I don't. Because remember, I'm only writing the possible x's. That's what I'm focused on here, the possible x's. Okay, now on to the next one, the range. Range of the possible y's. So I need to look through the information and see what I have here. I've got -5. I've got +8. I've got a 1 and a 5. So -5, 8, 1, and a +5. Like I said, it doesn't matter. And you can see they don't match. We don't have the same number of x's as we do y's. It's okay. At least for that type of question. Okay, let's move on to another definition here. The definition would be function. These are the group of relations that we're really interested in. They would be, and I need to define it. Each x has exactly has its own y value, or I guess I should say exactly 1. Okay? You'll notice in my, I think it's great to visualize it. So I took these coordinates right here and I graphed them. You can see them graphed down here. Okay, my best estimate at graphing them. And folks, it really just needs to be an estimate when you're doing this. It doesn't need to be perfect. Now, the next thing we need to talk about is how do I use that definition and see it visually? We have something called the vertical line test. Okay, I know. Whoops, I hope that's on screen and not above. Well, anyway, we will abbreviate that VLT, okay? So, vegetable, lettuce, tomato sandwich. The VLT is the vertical line test. We take a vertical line, pass it through the graph, and if it only hits one point at a time, we say that it passes. And if it passes the vertical line test, which this one does, passes, man, that's bad looking, it's a yes. If it fails, it's a no. Now, what does it mean to fail? It means that you have more than 1 point in the same vertical line. Let's take a look at an example like that. Okay, the next one is, I don't like a mapping diagram, and that's what I see right here. This is called a mapping diagram. Not a big fan. You can see that the 2 is connected to the -7. Well, what they're trying to show you is the coordinate 2, -7. And, lots of people say, well, why do they write it like that? Why can't they just write out the coordinates like normal people? I don't know. Not a fan. But anyway, so if we go through and we do, okay, 5 goes to -7, 6 goes to 21, 9 goes to -2, 9 goes to 14. So I estimate it. Now, you could see, not only did I estimate, I didn't even put a scale on these doggone things. So 2, that's my -7 right there. That's my 21 way up there, So, yeah, I estimated them. I wasn't trying to be perfect. And what did I find? Well, I started passing that vertical line through it, minding my own business, and then whammo right here. You see, when the 9 went to the -2 and the 9 went to the 14, we had 2 coordinates in the same vertical line. Therefore, it failed the vertical line test. And if it fails the vertical line test, it's a big no. It's not a function. And that's it for that, SWYK. So, go get those problems done. On to the next video. Have a great day.